Hey, welcome everybody to I Learned About Human Factors from That. This is episode 4, and we've got a very interesting accident to look at today. I'm joined by Scott Rexwinkle. Hey, Scott, it's great to have you back on the show.
Hey, Sam, how's it going? Good to be back. I really enjoy these.
Thank you. Yeah, Scott, today we've got a really interesting one. We're looking at a helicopter where, unfortunately, the use of degraded hardware that should never have been used again caused a accident and unfortunately a loss of life. So this is going to be a one to really dig our teeth into and find out what went wrong. And Scott, just for those people who don't know you, you're a pilot, mechanic, accident investigator, and a human factors fan. Anything else you want to
add? Father, we'll go with that. That's a big one in
there. That'll be for another episode where we talk about factors of family life.
Yes, absolutely.
Aviation. But for those of you who are new to this series of videos, the purpose of these videos really is to learn lessons from observing the potential human factors that contributed to the outcome or these accidents that took place. And I'm going to let you know right at the start the 3 things that we're going to look at taking away from this. We're going to look at learning about clearly staging work or task cards. We're going to look at the importance of managing fatigue and also discuss the importance of human factors training as well. And that's just to give you a bit of a preview of as what's coming up, because each of these areas played a significant part in contributing to this accident. So don't forget to check out the links below. They'll give you direct links through to the NTSB site and the dockets for this accident with loads more information that we'll be able to go into. Don't forget to subscribe and share as well. Thank you. So Scott, let's dive straight into this. We'll talk about this accident. And this accident happened on the 7th of December, 2011 at 16:30 Pacific time. It was a Sundance helicopter. It was a Eurocopter AS350-B2, and it crashed in the mountainous terrain about 14 miles east of Las Vegas. 4 passengers and a pilot were killed, and the helicopter was destroyed by fire. Now, if environmental conditions at the time were visual meteorological conditions, so good visibility, there was dusk light, which prevailed at the time of the accident. The helicopter originated from Las Vegas McCarran International Airport about 1621 with an intended route of flight to the Hoover Dam area and returned back to the airport. The accident occurred when the helicopter unexpectedly climbed 600 feet, turned through 90 degrees to the left, and then descended 800 foot, entered a left turn and descended at a rate of 2,500 foot per minute to impact. The investigation that ensued discovered that the main rotor aft servo, one of the 3 hydraulic servos that provided inputs to the main rotor, was found with its flight control rod not connected. The bolt, washer, self-locking nut, and split pin, or also known as cotter pin, that normally secured the input rod to the main rotor for aft servo were not found. They came away. The investigation concluded that the hardware was improperly secured during maintenance that had been conducted the previous day. The nut most likely became loose, possibly due to the degrading, and without a cotter pin, the nut separated from the bolt disconnected, and the input rod separated from the linkage while the helicopter was in flight. At this point, the helicopter became uncontrollable and crashed. So Scott, that was quite a short intro to this accident, but a very quick sequence of events that took place.
Yeah, it's a very unfortunate sequence of events, especially when you think about the FAA requirements for our helicopters and for the connections at these locations in these helicopters requiring dual locking devices. And we have those dual locking devices, and those requirements are in place just to prevent this type of incident from happening, to prevent these self-friction nuts from backing off. It's just extremely unfortunate where if you don't put the cotter pin in, or you put in degraded self-locking nuts, these are the type of things that can happen, unfortunately.
Yeah, absolutely. And, just reading through this, I'm reminded of another there are other accidents that have taken place where on helicopters where the circumstances have been really similar. So it's going to be really interesting to dive in a little bit more. Let's find out what happened from a maintenance perspective. So leading up to this flight, the day before the flight, a team of 4 mechanics, 1 inspector, had carried out a 100-hour inspection alongside replacing the engine, the tail rotor servo, and the main rotor fore and aft servo. 1 mechanic replaced the fore aft servo, 1 replaced the tail rotor, 1 replaced the engine, and 1 conducted quality control. So there's 4 mechs working. 1 of them assumed quality control.
No small maintenance either.
Say again?
That's no small maintenance either.
No,
there's quite a significant maintenance taking place on this helicopter. And, it's quite the chore and quite the undertaking. And especially in I guess they were running about a 12-hour shift. And for all these items that have taken place over this 12-hour shift is no small feat.
So looking at the helicopter's flight control system, and this is directly from the NTSB report now, because I thought, let's just take the facts straight from what the report said. The Eurocopter AS350-B2 helicopter is equipped with a single 3-blade main rotor system and a 2-blade tail rotor for anti-torque and heading control. The helicopter is equipped with a mechanical flight control system assisted by hydraulic tail rotor servo and 3 hydraulic servos installed on the main rotor, 2 lateral servos, which transfer the lateral inputs to the non-rotating swash plate for roll, and 1 fore and aft servo, which transfers the fore and aft inputs to the non-rotating swash plate for pitch. The system is controlled by the pilot actuated control inputs using the cyclic, collective, and anti-torque pedals. According to 14 CFR 27.607, any removable fastener whose loss could jeopardize the safe operation of the helicopter must incorporate 2 separate locking devices. So they worked on the fore and aft servo, and therefore they needed to obviously remove the fastener and reinstall it. And it should have been installed with incorporating 2 separate locking devices. So for this particular type of helicopter, the fore aft servo input rod, the first locking device is the self-locking nut, and the second one is the split pin or cotter pin. In accordance with the Eurocopter Standard Practices Manual, which references joining assembly by bolts and nuts, the self-locking nut is installed on the bolt and torqued to the minimum specification. The nut is further tightened up to the maximum specified until the hole in the bolt threads aligns with the slot on the nut. The cotter pin is then inserted through the nut and bolt, and the pin's tangs are bent open 90 degrees or more around the nut. So during post-accident interviews, Sundance mechanics, which is where the helicopter's maintenance was taking place, said that there was no difficulties in installing the servo. In fact, I believe they'd actually been involved in this kind of maintenance before, so it wasn't new to them. The mechanic involved said that he replaced the servo's upper rod end, reassembled it, torqued, and safetied everything, including securing the input rod connection with a cotter pin. However, as noted previously, there was no cotter pin found in the wreckage. So it either wasn't installed or it came away in flight. He stated that he then connected the hydraulic lines, retorqued all of the rod ends back to the flight controls. The mechanic estimated that he had performed this process 6 times before the installation of the fore aft servo on the accident helicopter, and stated that he did not encounter any difficulties during the installation on the day of the accident. And then Scott, the Eurocopter Standard Practices Manual provides guidance regarding the reuse of hardware on its helicopters. And I know we chatted offline a little bit about the reuse of hardware, and it specifically looks at the reuse of nuts and the criteria for reusing dual locking nuts. And it states the following, which I thought was interesting. Point 1, prior to reusing the nuts, make sure nylon lock is not excessively damaged. And secondly, fit the nut by hand. And if the nut can easily be tightened, you've got to discard it. If the nut is hard and cannot be tightened by hand, it may be reused. And in a workshop, the minimum locking torque value can be read using a torque wrench. So that's kind of what the details are up to this point, Scott.
Yeah, I know we had talked about the secondary locking device requirement from the FAA before, and on this particular helicopter, on the AS350, they used, like you said, the castellated self-locking nut along with the cotter pin. I know Robinson uses a self-locking nut with a PAL nut on top, which is essentially a jam nut configuration. And I think it was also missing the bolt, and the nut were missing as well at the accident site, which does make it hard to determine whether or not a cotter pin was ever installed. Typically, you can look at the threads or look at the hole where the cotter pin goes, or look at the castellations within the nut and tell if there was any type of relative movement between the two that would have sheared the cotter pin. Some sort of damage, either microscopically or just available to the naked eye. But lacking that hardware, you can't really positively confirm there was no cotter pin installed ever prior to this accident. But it's a very good indication that more likely than not, there probably was not a cotter pin installed, or else we would have been missing all of the connecting hardware for this actuator. I don't know if I mentioned earlier within your brief, but this was what they think the fourth flight of the day for this helicopter.
Yeah.
It had been pre-flighted earlier, and we can go ahead and assume, since it had three successful previous flights, that hardware was there and intact at some point within the day, and more likely than not had just departed this helicopter during the accident flight.
Yeah, and I wonder what the chances are. Let's assume for a minute, and this is an assumption. Let's assume the locking nut was on, and it was also safetied with the cotter pin. What is the likelihood that the cotter pin is going to come out, and then a new or locking nut that can be reused will then come off of the bolt? What's the likelihood that you'd lose the cotter pin and then the bolt?
I can't even imagine a situation where you would shear one if you had a properly installed cotter pin. The only way to remove that at that point would be to shear it, honestly. I mean, because there's no mechanism up there to unbend, straighten out, and then vibrate out a cotter pin. So we're talking about a shear situation. Well, the rotation up there at that upper end of that actuator to the lower non-rotating swash plate, I don't see any evidence of any type of movement that could be placed on that bolt to cause a rotation that would shear a cotter pin. So I don't think that we're in the area of a failed hardware, because I can't even imagine how remote, if you actually mathematically went out and did it, the idea of one, losing a cotter pin, and two, backing off a self-locking nut in the same flight, but yet having the other actuators in the same location retain their hardware, just doesn't make sense.
Yeah, and with all the hundreds or thousands of helicopters flying around with similar hardware, if we're working on these flight control systems, if we're working on any system that requires a locking nut of some type, and a secondary locking device like the cotter pin in this instance, there's a reason why they're there. There's a reason why when we're told to use nylock nuts, we've got to use the ones that are going to hold. And we kind of made light of the fact that sometimes possibly mechanics don't go and get a new one because they don't want to climb down and go get one from stores. But look at the consequence here of potentially reusing the nut, which should not have been reused.
Yep. I don't think the reuse of hardware is an uncommon practice in aviation means. I think it's very common. I don't know of any mechanic personally that doesn't have that drawer on their toolbox is full of old hardware, or that coffee can sitting up there that's full of old hardware. And when you need to find that one nut that fits it, you find it. But that thing is, when it comes to self-locking hardware, it's almost you kind of have your own personal minimums on that as well, right? You're kind of no go, right? If I start to thread that nylock on there and those threads start to engage in the nylon and it's not biting, and I'm able to thread it on by hand, chuck it. It needs to come off and go straight in the trash can. It doesn't need to come off and go into a bucket or into a drawer.
The mechanic indicated that when determining whether a nut can be reused, he removes it, cleans it, and then inspects it for any cracks or damage or discoloration. And the mechanic indicated that he then threads the nut on the bolt to see if it will thread all the way down. And if he's able to turn the nut down to where the shank is visible, he replaces the nut. In the case of the accident helicopter, he deemed that the hardware was airworthy. So that was his words.
Yep.
The NTSB, though, concluded in their investigation that the bolt connecting the control input rod to the fore aft servo's input lever must have been present at the start of the flight to allow normal flight up until the time of the catastrophic upset, but it was not present immediately before impact and post-impact fire. And then there's further evidence from the NTSB that concluded that the most likely explanation for the in-flight loss of control was that the fore aft servo bolt disengaged in flight, which resulted in the separation of the control input rod to the fore aft servo's input lever. Helicopter was totally uncontrollable. When they did their investigation, they looked at the self-locking nuts from a couple of other examined helicopters. So Sundance Helicopters provided the NTSB with self-locking nuts from 2 of the examined helicopters that they looked at after the accident that could be easily and fully tightened or loosened on the accompanying bolts with finger pressure. This indicated that the nuts from the 2 helicopters were not suitable for reuse because new nuts restrict movement by hand after 2 to 3 turns. So here's an issue. These nuts were being reused.
Yeah, it's more institutional issue now is what we're looking at, because it looks like the practices at this facility were just to reuse the hardware. And like we were talking about earlier, if we go and put on a nut, the self-locking mechanism has failed and is no longer sufficient, we're now solely depending on the retainment of that cotter pin to keep the stack up of hardware together. We've taken that backup out of play, and now we're relying on one item only, which is not the original intent of that FAR and that regulation for the secondary locking device. It's not the intention of it to make that secondary locking the primary and only locking device.
Yeah. So there's other things coming out of this as we're going through this and reading through this. There's some other things jumping out at me. Number one, there's a practice of reusing self-locking nuts that are not suitable for reuse. That's the number one thing. And there's a lack of insight into the mechanics asking what's the worst that could happen. There's no imagination to the fact that, well, if this fails, if that cotter pin that I put in somehow fails, and then this self-locking nut backs off, what's the worst that could happen? There's lack of imagination as to the consequences. There's bad practice. Based on that evidence, the NTSB concluded that at the time of the accident, Sundance Helicopters were not following Eurocopter and FAA self-locking nut reuse guidance, which led to the repeated improper reuse of degraded nuts on the helicopters. And so in summary, for the bolt to have been able to work its way out of the joint, the following had to occur. The nut tightening torque must have been overcome. The running resistance of the nylock locking feature must have been overcome, and the cotter pin must have been missing. And then on top of that, just thinking about the inspection that was done post maintenance, the fact the cotter pin was missed. Let's assume now for the moment that the cotter pin wasn't put in. Now we've only got the nylock hopefully holding, but the inspector missed the fact that the cotter pin wasn't there. So am I right in thinking an RII would have been done on this system?
I would have thought so. For this location and flight control system, I would have thought you would have had an RII for this. Absolutely. If those don't require an independent inspection, is what we're talking about when we say RII.
Absolutely.
And even then, I think we had this conversation in a previous episode where it doesn't bother me. It doesn't matter to me if an RII is required or not. I'm still always having someone else come look at my work. I always ask, hey, can I get a second set of eyes over here? Because a lot of times when you're too close to a project and you've been the one working on it, you will miss things. And it happens all the time. It's nothing to be embarrassed about. You need to be responsible and have that second set of eyes. It's a good practice and a good habit to get into.
Yeah, absolutely. And the inspector specifically stated in an interview that he inspected the fore aft servo input rod, the hardware, the cotter pin, and marked them with a torque pen, and that he had inspected the hydraulic lines that connect to the manifold. He reported that the items to be inspected are easy to access and are not blocked by other components. The inspector stated that he did not find any problems during the inspections. Despite these statements, as discussed previously, the evidence indicates that the cotter pin was installed improperly or was not present. Because that's the other thing. maybe it was installed, but it was installed improperly and came out.
I mean, it's an interesting thought. Improperly installed cotter pin. I mean, it's hard to do, for one, especially if you bend over the tail of it at all. The idea that even improperly would somehow work itself out, I find somewhat hard to imagine a circumstance where that would actually happen. But it's kind of one of those. How do you put a cotter pin in wrong?
Well, I wonder if it's like you said on one of the previous episodes here, you know, when we're talking about distractions, we've not delved into this deeply enough. I'm not sure if the report touched on the, you know, whether any of those mechanics were distracted, but let's play around with this scenario.
Yeah.
For a minute. You know, if the mechanic who's working on this servo, he put on the nylock, and then it was his tea break, or he was just interrupted by one of the other mechanics who needed a hand, you know, I don't know, helping to connect something on the engine, for example. And he just said, hold on a minute. And then he just literally slaved that cotter pin in his mind, possibly. And this is the thing with the distractions. Oftentimes when you're distracted, you'll go back to a task and you actually think psychologically, you can think you're further ahead than where you actually were in a task.
Yeah.
So, you know, this is,
I mean, reading through the briefing. Reading through the briefing earlier, you know, when it said that there was 4 mechanics working on this helicopter, and under the one, it said 1 mechanic replaced the engine. And that, to me, it was flags going off instantly. You have 1 guy replace this engine. That's hard to believe. Is you had 1 guy replace the fore servo. That's it.
Yeah.
So I think that, you know, this is all speculation, of course.
Yes,
and like we've said previously, we have the you know, the benefit of hindsight here, where we can look back at these things. So purely based on speculation, I'm going to go ahead and say I'm guessing that the guy replacing the fore servo was not replacing just the fore servo. I think he has some additional responsibilities, that he was, you know, helping the guy install the engine. They're both up on top of the helicopter. They're both in the same vicinity. So it wouldn't surprise me if the mechanic installing the fore servo additionally was helping to route some lines, to connect some hoses, whatever he ended up doing up there. And you're right, it may have been a situation where he thought he had put the cotter pin in, had a distraction. I mean, I have found fasters before missing cotter pins. You know, and you know, it was an item on a rudder pedal in an aircraft, and a mechanic asked me to come over and, as a second set of eyes, check everything over before he closed it up. And I'm looking it all over, and I said, "Did you want to put a cotter pin in this rudder pedal?" What? I didn't realize I missed that. You know, and it's not an uncommon thing where you put the hardware back on, you think you've cotter pinned it, and just forgot to.
And it doesn't mean you're a bad mechanic or a bad engineer, or
absolutely not
to do that. It's just this is human nature. You know, we're influenced by human factors. We're influenced by distractions or pressure or stress to get an aircraft or a helicopter out on time. And actually, additional barrier there to safety and preventing errors or minimizing the potential for error is to use the team around us, and to acknowledge the fact that regardless of the amount of experience we've got, we're all fallible. We can all be in a situation where we can make a mistake or make an error. And I just don't, you know, the fact that these mechanics stated, you know, that he assembled it correctly. The fact that the inspector said, yeah, I inspected it, had a look, and I believe signed the paperwork as well to say as much. Sometimes it's easy to be working on something and look, but not actually see. Yeah. And sometimes we can expect to see things that, you know, and that expectation can actually mean that we miss stuff.
Yeah.
So I think it's, you know, that's really important. Just to, it's the whole stopping to think, you know, it comes down to personal minimums again, doesn't it? And I think we mention those every time, but it really does.
Yeah.
And the NTSB concluded by stating the following: they determined that the probable cause of this accident was Sundance Helicopters' inadequate maintenance of the helicopter, which included, firstly, improper reuse of a degraded self-locking nut, secondly, the improper or lack of installation of the cotter pin, and thirdly, inadequate post-maintenance inspection, which resulted in the in-flight separation of the servo control input rod. and that led to the aircraft crashing. Contributing to the improper or lack of installation of the cotter pin was the mechanic's fatigue and the lack of clearly delineated maintenance task steps to follow. That's interesting. So they're talking about fatigue here.
Yeah, this is a very interesting little caveat to this whole story. The work cycles and the duty, the hours they had been on and the hours they've been off. And go ahead, I'll let you.
Yeah, no, I was going to say, do you want to talk a little bit about that?
No, go ahead. I found it very interesting. So the mechanics, the guy that was working on the fore servo, he had a work schedule of 4 on, 3 off, and then reversed to 3 on, 4 off. And his typical workday is about 11 hours. And let's see, the days that he worked, 4 days on, he had 11-hour work days. And on the 3 days on, he had a 12-hour work day.
Yeah.
But what was interesting, I thought, was that leading up to this accident, I think it was December 4, 5, and 6, he was supposed to be off work. And then they called him on the 5th and said, we need you to report to work on the 6th. And it wasn't for his typical shift that he was reporting for. He normally reported for his shift at noon, but on this particular day, they asked him to come in a day early, and he was reporting at 6 a.m. for the start of his shift. All of a sudden, he's got his rhythm down to where his sleep cycle, when he goes to bed, when he wakes up, and that's normal for him. And then all of a sudden, he's asked to come in a day early, and not only that, change the shift that he normally works as well. And we were talking about this before we got on here, but I remember, our first newborn and that whole, and just because I have never worked night shift work, because I know I'm not good at changing my rhythm and working nights. So I've never done it and never put myself in that situation because I know it's not a good idea. But that was amplified by the fact when I had my first child, our first newborn was up in the middle of the night, my sleep schedule changed, and I have never been foggier in the head coming into the office than I was when first year of life, right? It's quite the change. And to get yourself to alter your sleep schedule and get used to that, to where you're not feeling off and you are thinking clearly. So the mechanic that was changing the fore servo, his schedule had changed. But I think also the inspector, his schedule changes also, right, Sam?
Yeah, it had. Yeah, he got called in as well. So obviously this was, I don't know whether it was lastminute.com kind of 100 hour, but all of a sudden they needed to draft some people in to get this thing done. So I wonder if there's a bit of pressure going on here as well. We've got to get this helicopter done. We're low on people. You guys are going to have to come in on your day off. Yeah, and that's kind of what it sounds like was kind of happening, is that they had maybe through scheduling or whatever, they had this helicopter had slipped through as being due, and they had scheduled charters or scheduled tours already booked, and they didn't want to have to alter those. And so they're calling these mechanics in early saying, hey, we got to get this done and get this back out. I don't know. What I find interesting, though, is the engine change itself. Why was this helicopter getting an engine change? Had something happened at some point in the days leading up to this that required an engine change all of a sudden? Or was it that they had been planning to do an engine swap, and the engine they were swapping had just showed up, and they like, hey, we got a window, let's get this thing in and get this done. And while we're at it, one says, well, while we're at it, we throw this at it, and stuff started piling up. I don't know. It'd be an interesting, unfortunately, I don't think the NTSB got into the depths of some of those surrounding circumstances that may have been putting some external pressures on these mechanics to try and get this job done and get this helicopter out the door. And that's the thing. There's always other contributing factors. And so this is why it is so important, to consider human factors, consider fatigue, consider shift patterns, consider the work that you're doing, consider whether you're being distracted or not, or the pressure that you're under, and how that might influence you when you're doing your task, carrying out tasks. And also why, when you're doing an inspection, to be dedicated to that inspection and to reduce distractions as much as possible. And the other thing which the NTSB pulled out here was the facts about the work cards and the recording of the maintenance that was the guys were on. And they said it was likely that the maintenance personnel's performance was also affected by human factors that have been identified through research to affect the reliability of maintenance and inspections. For example, research suggests that even well-trained, experienced mechanics can inadvertently fail to detect a defect. These failures can occur for various reasons, including the inherent challenges associated with conducting systemic visual inspections, complacency and expectations, and the over-reliance on memory for performing tasks or identifying critical areas for inspection, and interruptions, which, to be honest, they're very common in maintenance environments.
Absolutely.
So going back to Workcards here, using documentation that clearly delineates the steps to be performed and the critical areas to be inspected to support the maintenance and inspection task is one way to mitigate all of these factors. So, you know, thinking how work cards are compiled, how they're put together, or task cards, and signing off as you go or stamping as you go. I know that the companies I've worked with over here in Europe, that's very commonplace now. They'll take the AMM, but then they will, from the AMM, they'll break it down even further into the task cards.
Yeah.
And they'll.
No, I think that's a great idea. Is you know, from working in Part 91 over here in smaller GA shops, it's not something that's commonly used. You know, we do have our checklist that we do use every 100-hour, 50-hour annual inspection. But when it comes to individual tasks, especially on fixed wing aircraft, you know, for like say the servo replacement, it would be really nice to have a checklist or a card to go along with that servo replacement and say, all right, item 1, item 2, item 3, and then you can go through and you physically check off that you've completed these items. And it's just another portion of reassurance in addition to the RII, or the second set of eyes and inspector that you have come on to verify the work that you've completed. You've got the secondary checklist here that also verifies, yes, I physically did that. I did that. And you check, got down a list of all the steps that you needed to complete to make sure the task is done completely correctly. So I like that idea. I wish we had some more of that in some of these smaller GA tasks, and especially some of the more routine accessory and component replacement tasks. I think it'd be a wonderful little checklist to have for those.
You know, with this accident, the NTSB concluded that all maintenance personnel would benefit from receiving human factors training, including training on the cause of fatigue. And the FAA do a great grounded video on fatigue, its effects on performance, and actions individuals can take to prevent the development of fatigue, which would help to reduce the likelihood of human error in aviation maintenance. So, Scott, that's what, you know, what are the 3 things that you think we can take away from this?
If we can work up with more detailed tasks and work cards and really document those items within our task, that we've checked that box, we've completed that portion of this task, we can move on to the next. It's going to help us out a lot in verifying the work is done completely. So I think that, detailed work task cards is a big takeaway from this. That's good. And then secondly, I think, you know, we need to consider how long hours and changes to our shift patterns can contribute to buildup of fatigue. And we need to be thinking, you know, if I'm coming back in, maybe on a day off, maybe I've come in because I want to help out, but I'm feeling fatigued. I think it's important to ask ourselves when we're traveling to the airport or the facility, you know, how fatigued am I feeling right now? How much sleep have I got right now? Because it's a great self-awareness thing. And to be that self-aware will actually help us and make us think, okay, well, actually, I didn't get a lot of sleep last night, maybe because of some family circumstances going on, maybe for health-related issues. Maybe there's other things on our minds. Actually, to identify, and this is just about fatigue, we should be doing this about other human factors like pressure and stress. But by identifying that, we're preparing ourselves and we're actually being proactive and thinking ahead about how we can minimize the potential for error. And it might be that when we get to our place of work, we just need to say, hey, you know, I'm feeling a bit tired today. I'm going to go ahead and do the best I can, but do you mind just having a quick look over my shoulder and checking that task I've done? I'm going to be all right. Going to get some coffee, going to get some, you know, caffeine into me, and I'm going to eat well today, but just in case, because there's always the chance. Absolutely. And then thirdly, Scott, I think, you know, we haven't mentioned this, I don't think yet in these episodes, but human factors training. There's some great stuff out there, and human factor training just keeps people
on the cutting edge of minimalizing the potential for error. And, you know, anybody out there watching this video, if you've got to the end of this video, thank you firstly for watching all the way through to the end. Would love to hear comments from you. I know Scott and I would be grateful for any feedback on the direction you want these videos to go in. But also on human factors training, if you're a safety inspector or responsible for training in your organization, and you want to have a look at the way we've created the human factor course, we can give you full access, open access to the whole course. You can see what it's about. And even if you don't, you know, use it from us, it might just spark some ideas of how you can develop your own programs. And that for me personally is the most important thing that could come from that exercise. So yeah, Scott, any last words before we close today's episode?
No, I think that's great. I think we covered it, but it's always good meeting with you and talking through these things. And, you know, it's funny, as much as we prep for them and try and prepare ourselves of the items within the actual accident itself, when we read through it and do the video, more things always pop out every single time.
Yeah.
Know?
I think we could, you know, if we ran this one again, we'd end up with a bunch of other stuff.
I'm sure.
So everybody who's watching, thank you so much for your time. Be blessed, and remember your personal minimums. Scott, till next time, thank you very much, and I'll see you next time.
Have a good one, Sam. Thanks.
Bye-bye.